A ladder 5 meters long is leaning against the wall. The bottom of the ladder is pulled along the ground away from the wall at a rate of 2 centimeters per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? So we can talk about this in the following manner. So we have a wall and a floor, and we have a ladder. Right? Say this is the initial condition. Now what they're telling is, if this were the initial condition, right, the ladder will get displaced in this manner. Right? Actually, it's very little, but I'm going to show in this way so that you guys can understand it better. So if I take this as x, or say 2 meters away, within 1 second this will be 2.02 meters. Or if I take this as, let me convert everything to a centimeter because it's easier for you guys to understand. This would be 202 centimeter, and this would have fallen up to certain height. So that's what we have to figure out. So this is happening every second. Okay. So what will happen to the length of the ladder though? So it will reduce or increase? Obviously neither. Why will the length of the ladder increase or decrease, right? So this is 500 centimeter. 500 centimeter. So this you guys have to keep in mind. Now, the whole funda is the fall along the vertical has to be linked to the movement along the horizontal. How will we link it? Movement along the horizontal. How to link this to? Think. That's the main funda. If you guys think this, then it will make sense. If not, you're just by hearting the answer. With the help of the length of the ladder. Length of the ladder is the one which is going to link this to set of, well, values or concept and all of that. Okay, let me show how to do this. So we have been given the length of the ladder to be L. So this is basically 5 meters, which is 500 centimeter. Again, the answer starts from here. We have to show all the working. Now we have dx by dt, that is the movement along the horizontal, to be 2 centimeter per second. Right? We are trying to figure out what is happening to the height with respect to time, especially for a case wherein you have that to be 400 centimeters away from the wall. Again, converting everything is very important. Here things are in meters, I convert it to centimeter. So basically put a diagram for your exams, because this will require a clear understanding and clear usage of variables. So something like this, and this I'm going to take it as x, and this I'm going to take it as y, and this is 500 centimeter, and this is 90 degree. So how is the length going to relate this to? It's a very simple, straightforward question. Yes, with the help of Pythagorean theorem. Does it make sense? Okay, what does the Pythagorean theorem tell? Well, if I square the hypotenuse, that will be equal to the sum of the square of the other two sides. Now what should I do? Well, we can differentiate this. Differentiating the equation with respect to time. So if I differentiate a constant, what will we get? Yes, 0, because the length of the ladder is not changing. See, differentiation works. This is 2x dx by dt. How far it is from the wall, that can change. How high it is from the ground, that can change. That's why we have these quantities, right? See, this indicates, it's a very important thing for you guys to understand, that the ladder length does not change with respect to time. And so this is 0. Okay, such small things if you understand, then the concept becomes very clear. Now we can substitute, well, we know x, we know dx by dt, we don't know y though. So we need to substitute x to be, they are talking about 400 meters away. So 4 centimeters away, 400 centimeters away. And dx by dt is, it is moving at a rate of 2 centimeter, right? I hope I'm right about that. Then we have y, yeah. How, see, we don't have y. We need to find dy by dt, that's okay, but what will I substitute for y? Yes, square root of 500 square minus x square to the power of half from the Pythagoras theorem, right? And so finally we have 0, 2 into 400 into, this is 2 again, plus 2 into 500 square minus x square. Okay, let me write this only, and dy by dt. A bit of simplification and we are done. So let me transpose dy by dt into 2 into, so this I'll take 100 out and we'll left out with 5 square minus 4 square. I hope you guys are, decent with your maths to understand this. So there is 100 that is common between these two elements, right? So actually 100 square, right? I took common, and we have a square root also. So all in all, we have 100 that is common, right? And this is equal to 2 into 4 into 2, 2 into 400 into 2. So this will be 4 za, this will be 1 za, 8, and this will be 25 minus 16, 9, 3. And by the way, this is negative, right? I transpose this term, so it's negative, and this is 8 basically. So dy by dt is minus 8 by 3 centimeter per second. I think it's second. I don't want to make the same mistake. It's second, yes. So finally we can summarize that the top of the ladder is falling towards the ground at a rate of 8 by 3 centimeter per second. It's important for us to summarize whenever we get word problems. Falling and 8 by 3 should be marked, right? Okay, so again, if you guys understand the things that will link and write the given, your answer is done. For every question, you should be doing that before I answer.